press only the sideband power remains, wherein it only carries on the information. In the carrier amplitude modulated by single sine wave, it results consists of three frequencies, the carrier and then your upper sideband and the lower sideband. At 100% modulation, two-thirds saving is affected and more is saved upon the reduction of modulation. So parang sinusuppress natin yung carrier na tatanggal nga wherein the two-thirds is yung napupunta namin sa carrier. It's already being saved. So this is the calculation for total sideband power PCM squared over 2. Tapos pag tinitingnan natin in every sideband, so it is over 4, lower sideband or the upper sideband. PCM squared over 4. Here's and for example for the calculation of percentage power saving. When a carrier and one of the sidebands are suppressed in an AM wave modulated to a depth of 100% and 50%. So, paano natin siya i-compute yung percentage power saving? Ito na po yung formula, total power minus your power of a sideband over the total power. Paano pag yung modulation index or the depth of the modulation is at 100% at paano kapag 50%? Total power calculated as PT times PC times 1 plus N squared over 2. Paano yung sa power of a sideband? Of a sideband, sabi nyo. Ilang percent power saving? Ilan? ECE, cameras. Ilan kapag 100%?
Sir, 83%?
83.3%. Good. Paano kapag 50%? Ay.
Sir, 94? Tama ba, sir?
94.4%.
0.4.
Okay. Good. Paano mo, ano yung sa power of a sideband na ginamit mo? Is it over 2 or over 4?
Sir, over 4 kasi isa lang.
Oh, power of a
Nasuppress,
sideband.
nasuppress yung isa.
Yes. Kung nag-gets nyo po ba? So, total power, ito yung sa calculation, PT. Or since kahit naman tanggalin mo na yung sa may PC, parang ina-analyze mo na lang siya through. Ito, 1 plus m squared over 2. Tapos yung power of a sideband, so 1 plus m squared over 4. Ito ng total power, 1 plus m squared over 2. So, given lang at 100% and 50%. So, kapag 100%, it's 83.3%. Kapag at 50%, it is 94.4. So, the lower the modulation index, mas nakakapag-save ka pa ng it saves you more power. Kuha. One application ng ganito nga, yung may suppression is in mobile communication. Okay, how about pag suppression naman ng carrier? So, there are three main systems. Ito yung katumbas na mga technology wherein we have my filter method, phase cancellation method, and the third method. And all methods use balanced modulator to suppress your carrier, which is a key now to single sideband na technique. So first, we have their balance modulator. It becomes the means to transmit a signal without the clumsy and the wasteful energy ng carrier. So a balance modulator circuit that generates a DSB signal, double sideband signal, and it suppresses the carrier and leaving only yung sum and difference frequencies at the output. So yung mga sidebands. So yung output ng balance modulator can process by filters or phase shifting circuits to eliminate one of the sidebands, so resulting now to a single sideband. Ang mga types ng balance modulators, so ito yung mga pinaka-common, mga lattice, yung 4096 and 1596 ICs, and mga analog multipliers. Ayan, lattice type balance modulator, popular and widely used balance modulator. Yung ginagamit is yung diode ring or lattice modulator. Consists ng input transformer, and then output transformer and 4 diodes connected in a bridge circuit. Ayan, kailangan nyo din maging familiarize sa mga even dun sa mga figures or circuits of modulators. Minsan lumalabas siya sa mga board exam. So, by description, meron siya sa input daw transformer, meron din sa may output, tapos may bridge ring ng mga diodes. About pag IC balance modulator, so most of the ginagamit is yung 4096 and 1596 na IC. Can work at a carrier frequencies up to 100 megahertz or can achieve carrier suppression around 50 to 65 decibels. Siyempre, hindi ko na kaya ipakita since it is an IC naman. So just know yung mga technicalities na pwede for that specific ICs 4096 or the 1596. So suppression ng unwanted sidebands. So ayan, we have the filter method. So ito yung katumbas po na block diagram for a filter method, which is the simplest system. Yung unwanted sideband is removed and actually heavily attenuated by a filter. The filter may be LC or crystal, ceramic, or mechanical, depending sa carrier frequency and other requirements. So, filter method. Yung modulating signal, your AF, is applied to the audio amplifier. Laser pointer. So, your AF applied into your audio amplifier. And then the amplifier's output is fed to one of the input of a balance modulator. Ayan. And then so crystal oscillator provides naman your carrier signal, which also apply to the balance modulator. So the output ng balance modulator is a double sideband DSP signal. So tas ma-apply siya dun sa may sideband suppression filter. So an SSB signal is produced by passing the DSB signal through your highly selective na mga bandpass filters. And through your filter method, it is, and after sideband suppression filter, through a filter method na ginagamit through the balance mixer, ayan na mamimili na siya, necessary to select either your upper or the lower sideband yung magiging result as an output. Another illustration, so dito sa banda dito, yung nagkakaroon na siya ng selection, it's either the lower sideband or the upper sideband yung as an output or will be demodulated. Ito more on the yung ginagawa no sa system, more explanation lang kung paano ayan, since may mga values. Pero if you will look into it na maintindihan mo agad, basta sundan mo lang yung sa as long as you are aware din kung ano yung mga ginagawa no every block So pinakakailangan mo lang naman dyan, para sa yung mga balance modulator, amplifiers, and then yung mga filters. Pag balance mixers, pag mixers yun nga, mix din, signal. Modulator, multiply, pag balance mixer, parang addition yung pinaka-operation na nangyayari. Ayan, sideband filters, ayan yung meron tayong crystal, ceramic, mechanical, and surface acoustic wave filters. More on today's yung about dito sa mga sideband filters. Ayan, crystal, ceramic, mechanical, and surface acoustic waves. Ito masi naman siya na-discuss, pakibasa na lang doon. Yung more technicalities more on these filters. Next, phase shift method. So phase shift method avoids filters and some of their inherent disadvantages, make use of two balance modulators and two phase shifting networks. So nagkakaroon ng phasing method ng single sideband generation, uses phase shift technique, causes one of the sidebands to be cancelled out. Phase carrier phase shift at 90 degrees. They are both shifted in 90 degrees and applied to another balance modulator. And then phase shifting causes one of the sideband to be cancelled out upon entering dito. So na-cancel na phase shift na siyang isa. So isa na lang yung pinaka-output when the two modular are added together. Naka-cancel out yung sa isa. And same lang din yung discussion dito from dun sa block diagram. Third is yung Weaver method developed by Weaver. Ito has the advantage of the phase shift method, such as its ability to generate a single sideband at a frequency and use low audio frequencies without yung associated disadvantages ng AF phase shift network to operate over large range ng audio frequencies. So yung third or the Weaver method, so gumagamit din siya ng balance modulator, tas may phase shifter din siya. And then may filler, para most of the most likely parang pinagsama yung first and second na method. So advantages and disadvantages. Advantages ng single sideband techniques. It allows better management of the frequency spectrum. More transmission can fit into a given frequency range that would be possible with double sideband signals. So parang mga less bandwidth, all of the transmitted power's message power, none is dissipate as carrier power. So may power saving, noise content, so may less noise, tapos may noiseless fading. So sa disadvantages, yung cost, of course, yung cost is the dami yung components mo. Nagkakaroon ka ng other mga such as filter methods and so on and so forth. The average radio user wants only to flip a power switch and a dial a station. So complex din yung nangyayari dun sa part naman ng technology. Okay, forms of amplitude modulation. So E and standard AM double sideband full carrier, and most of the time is for broadcasting. So and so forth. So pakibasa lang. Pag tinignan natin on the frequency domain, na kung ganito yung nangyayari. So sa double sideband full carrier, so and meron ngayong carrier. Ito naman suppressed carrier, so nakikita lang natin yung two carriers. Pag H3E, meron yung carrier at the same time yung one single sideband. Single sideband suppressed carrier. And meron din dito sa definition saan siya most likely ginagamit. Okay. Information is present only in the sidebands. Important na discuss na most of the time, most of the notes dito. So single sideband modulation, it is a single sideband suppressed carrier, a form of amplitude modulation in which the carrier has been cancelled out. Ulit lang. Okay, another example, problem. So an AM transmitter is rated 100 watts at 100% modulation. How much is required for the carrier? What is the power required for the audio signal? How much is required for the carrier? An AM transmitter at 100 watts given at 100% modulation. So meron tayong modulation index, percent modulation at 100, and then your power, total power transmitter is rated 100 watts. So how do you compute for the required for the carrier and for the audio signal? Diba nabanggit natin to kanina? How about for the audio, how about for the carrier? We already have given PTO. So PC times, ano yun?
Sa carrier share, 66.67 watts.
And how about for the power record for the audio signal?
So yung natira nun?
Anong gagamitin dun, sir?
Yung natira?
Yeah, yung natira
yung 33.
mismo, yun na yung for 33.8 for the audio signal. Siyempre, expected naman yung buo yung transmit na. Alangan naman, ito yung total. So yun naman yung natira para pupunta sa mga sidebands wherein it carries now your information, di ba? It is not the carrier that carries the information but through your sidebands. So tama yung binanggit kanina dun sa that it is pag 100, di ba 2/3 yung kinakain daw ng carrier. Tama? During 100%, 2/3 of the total power is wasted in the carrier. And the carrier power percentage is 33.3%. So, ayan. Yan mismo. Okay, product detector. So, a means of single sideband detection. Ito naman in the end of parang dun sa reception na side, of gumamit ka ng mga single sideband, paano naman very successful in the receiver side. So, ang ginagamit is a product detector mixing of high frequency component and an incoming modulated signal of a multiplier circuit followed by a low pass filter. So, advantages din ng ito ng single sideband, nabanggit na to kanina, power saving, less bandwidth, noise reduction, and selective fading. Disadvantages nga, ayan, complex receivers, kailangan mo ng tuning, kaya nga complex din yung circuit, and dagdag gastos lang doon sa mga components na kailangan. Independent sideband system, so multiplex techniques